Okay, today we're talking about comparing and ordering different types of numbers. This video is probably going to be a little bit longer than the videos that you've watched so far for the course. So you might want to pause, take a break, and come back. You only have the one video to watch for this lesson, so once you finish this one, you should be ready to take the quiz and come to class tomorrow. So again, the topic is compare and order numbers. I'm going to start with lists of numbers that are all the same type of number. So we'll look at a list of decimals, then a list of fractions, a list of radical numbers, and at the end we will mix them together and see how we do. So let's start with just a reminder about the number line. This isn't on your notes page, but I think you're probably aware of how the number line is organized. We know that 0 is in the middle of the number line. We call it the middle even though it goes on forever in both directions. As you move to the right, the numbers on the number line get larger, and to the left, the numbers get smaller. So when we look at numbers ordered on the number line, we know the smallest numbers are to the left and the largest to the right. So let's look at a decimal number like 1.2. How do we know where 1.2 falls on the number line? Well, the thing to do is look first at the digits that come before the decimal point. So in this case, that's just a 1. And that tells us what two whole numbers does this decimal fall between on the number line. This number has to be more than 1, but less than 2. Because if it was greater than 2, that digit before the decimal point would be a 2. So we don't know exactly where to put this on the number line, but we know that's somewhere between 1 and 2. Now let's compare this to another decimal number, 1.28. Which of these is larger? Which falls further to the right on the number line? To figure that out, since they both have the same digit before the decimal place, we have to look at the numbers after the decimal place. So in 1.2, after the decimal point, all we have is a 2. In this number, after the decimal point, we have 28. We don't want to compare the number 2 to the number 28. It's important that when you're comparing decimals, they both have the same number of digits after the decimal place. So I need to add a digit to this number so that it has 2 digits after the decimal point, like this one does. It wouldn't be fair to add anything except for a 0. If you add anything other than a 0, it really changes the number. So what we want to compare is 20 with 28. Since 20 is smaller, this whole decimal number is smaller than this whole decimal number. So we would say 1.2 is less than 1.28. So you go ahead and use those ideas and try to put the rest of the numbers on your notes page in order. You know, pause the video. On the next slide, I'm going to show you the answer. So the smallest number in the list I gave you of decimals is negative 0.7. That number falls furthest to the left on the number line. Then negative 0.5. So even though 7 is larger than 5, we're in the negative part of the number line. So the 0.7 has to be closer to negative 1 than 0.5 is. When we get into some positive numbers, we have 1.2, and we already figured out that 1.28 is larger than that, and the biggest number in the list was 2.9. Okay, now let's look at some fractions. 1/3. How do we know where this falls on the number line? The thing to do here is divide the denominator into the numerator. How many times does 3 go into 1? Well, it goes in more than 0 times, but not 1 full time. If the numerator was larger than the denominator, then that would mean that this whole fraction was larger than 1. It should go in more than 1 time. But we are going to be somewhere between 0 and 1. Now, if we compare this number to 1/5, 1/5 is also between 0 and 1, but we don't know if 1/3 is greater than or less than 1/5. So you probably remember back in elementary school, when you first learned about fractions, you had these pi circles, and you could break them up. You say, to represent 1/3, we break this whole into 3 parts, and to represent 1/5, we break this same whole into 5 parts. Then if we just compare 1 of the thirds to 1 of the fifths, we can see that 1/3 is bigger than 1/5. And it's always going to be true that if the more pieces you break something into, the smaller piece you get. So we can look at the denominators and they kind of have an opposite relationship. The bigger denominator makes the smaller fraction as long as the numerators are the same. It might be helpful for you to memorize and understand these conversions between fractions and decimals if you don't have them memorized already. 1/10 is the same as 0.1, 1/5 is the same as 0.2, a quarter or 1/4 is 0.25, a third is about 0.33, it's actually a little bit bigger than that, and 1/2 is 0.5. This can help you as you look at different fractions kind of visualize where they belong on the number line. So go ahead and use these tools and try to put your fractions in order. One-fifth is the smallest. We already said that's about 0.2. Then 1/3, that's about 0.33. So if you remember ordering the decimals, we know 0.33 is greater than 0.2, so these have to go in this order. Next is 2/3. 2/3 is going to be bigger than 1/3. It's going to be twice as big. You had a third, you added another third to get 2/3. 5/6 is very close to 1. It might have been difficult for you to figure out which of these two was larger, either 2/3 or 5/6. So a good way of doing that would have been to rewrite 2/3 with a different denominator. Remember when we talked about writing equivalent fractions. So instead of 2/3, that would be the same as 4/6. That's not as big as 5/6. And then finally, the only fraction on the list that was greater than 1 was 6/5. Remember what I said, if the denominator is smaller than the numerator, then this can go into the numerator more than one time. You already should know how to compare radicals. We talked about that once already, but I'll do a quick review here. If we look at the square root of 27, that's not a perfect square, but we know that it has to be between the square root of 25 and the square root of 36. And these are perfect squares, so we can take their square roots. The square root of 25 is 5, and the square root of 36 is 6. So we know the square root of 27 is between 5 and 6 on the number line. So using that idea, we can write in order the radical numbers, the square root of 6, then the square root of 12, then 5, it's the same as the square root of 25, the square root of 27, and 6, which would be the same as the square root of 36. Okay, so now you have some good rules. Let's see if we can get these numbers in order on the number line. I'm going to actually put a number line here because since we have all different types of numbers, I thought it would be easier if we actually go ahead and assign them to a position on the number line. So we'll start with the square root of 8. We don't know exactly where that belongs on the number line, but it has to be between 2 and 3. Then -4 is already marked on the number line, so we can just put that right at the -4. Same thing with the +3. -4.5 should be between -4 and -5, about halfway between. And 16/5. How do we figure out where that belongs? Well, 5 goes into 15 3 times. So it goes into 16 a little bit more than 3 times. Somewhere between 3 and 4 is where this belongs. So we can just order those numbers exactly like this. Okay, I think that was a lot of information. You might want to watch the video again, but if you are feeling comfortable, you can go ahead and try the quiz, and we'll get some more practice tomorrow. Good job.